we'll get this thing going. I'm very excited about today. My name is Rob Eddy. I'm the Technical Director of Resource Innovation Institute. You're here at the Efficient Irrigation Techniques and Water Reuse Workshop. This is one I've been looking forward to. Our expert panel features two of my horticulture heroes, Derek Gambrel, CEO of Redwood Remedies, and Andrew Lee, Global Technical Knowledge Manager of Grodan. They come from two different universes and they meet here today. And this is something that REI is good at, is bringing people together from diverse parts of the industry and joining them up. And they're going to share their experience today. Derek is a craft cannabis grower in California of great repute. And Andrew is a researcher and product developer and grower, you name it, from the Netherlands, works with fully scaled high-tech greenhouses that I believe will be the future of our work here in the United States. So this nexus of craft cultivation and Dutch technology is where I believe the industry is going. They'll exist both side by side and within each other. So listen close. This is a rare moment, and let's get started. I'm going to have Mary Lucas McDonald, who is the Tool Lending Library and Class Coordinator for Pacific Gas and Electric, get us started today with some introductory slides. Mary?
All right, thank you. So next slide. As Rob said, my name is Mary McDonald. I do head up our educational activities at PG&E related to agricultural topics, and I run a tool lending library. So if y'all need a flow meter or anything to measure water use in your facilities, let me know. I can loan it to you for free, as long as you're in California. Oops, on the disclaimer, it just says that we are illustrating typical situations here. They must be appropriately adapted to your circumstances. On the next slide, if we do, this is a webinar, so we may hear from you, we may not, but if we do have any video images or sound recordings, this is you giving us a release to use those in our promotional materials. Next one. And then we always have a safety message at the beginning of our classes. So in the event of an earthquake, drop, cover, and hold. For emergencies, have an evacuation plan. Discuss with your family and your coworkers. Where will you meet if you have to leave? And then be sure to check that everybody's there and let emergency response folks know if anybody's missing. And then also you should have your emergency plan, and you should pack a go bag, which includes all of your essentials should you have to leave at a moment's notice, and include those lovely pets of yours. And then stretch and get up and move. During class, we won't have any official breaks, but please, every 30 minutes or so, it's a good idea to get up, stretch, and get that body into motion just a little bit. And we are getting out of COVID, I hope, but we still should be practicing social distancing to some extent and following CDC and local guidelines. And you can go to that website, Emergency Preparedness, to get emergency resources. Do want to let you know that at the end of the class, we are going to have a survey for you. I'll put the link in the chat box. There's a lot of multiple choice questions, but we also really appreciate your written comments. Your input is super important because it helps us continually improve our offerings. So please do take a minute to fill that out when it's put in the chat box, and REI will also include a link in their follow-up email after class. Then I think it goes to you, Rob. There we go.
Right. I'm going to do a few introductory remarks as well. And a reminder that we are here to interact with you. If you have questions during the presentation, you can write them in the chat box and Carmen will alert me to them. She'll also save most of them till the very end. We're going to do about, let's say, an hour and 5 minutes of pretty intense instruction. And then we're going to open it up and let the panelists answer questions from you, and we'll save up all those questions. And of course, as ones come up at the end, you're welcome to raise your hand in the chat or in the Zoom window, or again, write it in the chat window. So I'll get on with our first poll. We love to do these polls during the workshops. This gives us an idea of who the audience is. So if you could write out what size is your operation or the standard operation that you serve if you're a vendor, if you could answer that during this section, and we'll go over it at the very end. We appreciate that. So we're going to introduce our panelists today. Again, I'm Rob Eddy. I'm the technical director of RII, and we're a nonprofit organization that focuses on sustainability. My background is in greenhouse management and research. I was at Purdue University for 20 years as their plant growth facilities manager. I also did that in the corporate world for Dow AgriSciences and their research greenhouses. And I've also been a consultant in the cannabis industry and in the ag chem industry and in the hydroponics and vertical farming industry before joining RII, which is a blast because the sustainability stuff is the most meaningful to me. So next, I'll turn it over to Andy Lee. Andy?
Yeah, good afternoon, everybody. Yeah, I've been involved in protected horticulture, I think, since 1996. Started off in a research role, joined Grodan in the end of 2000 as a technical consultant. Spent, best part of a decade providing full crop consultancy to Grodan's customers. In as far away lands as Australia, New Zealand, Japan, Korea. Spent a lot of time in the US, Mexico, and Canada. Also. Poland, and since 2014 I've had a global position looking after the knowledge program across all of the crop groups of which are our interest, and of course our focus is root zone management and water, so hence the reason for me being here today.
Thank you, Andy. Derek, you want to introduce yourself?
Derek Gambrel, owner, operator, and CEO of Redwood Remedies. We are California licensed cannabis cultivators, running nursery, mixed light, outdoor cultivation, also do processing and distribution. Studied under Rob at Purdue University, worked my way out to the West Coast about 20 years ago, and established Redwood Remedies in 2013, and generally focusing on craft cultivation, unique genetics and cultivars. Also hold an OCal organic cannabis certification here in California.
Spectacular. Thank you, Derek. Derek brings that land grant university education and then built his own business and became this renowned grower and breeder. And I love that he's also an organic grower. That's the sort of experience that we all need to learn from as well. And I just want to say that one thing about Andy is there is one guide called the Best Irrigation Practices for Greenhouses, and that I thought was a fantastic resource. It had information in it that I couldn't find anywhere. And then later on, as we were planning this workshop, I learned that Andy was the lead author. So that's one of the reasons I'm excited, the background of this panel. Yeah, I'm going to move on to some more introductory things. I want to mention that, of course, we'll be talking about irrigation. And we often, of course, think about how that helps the plants. But I think it's important to remember there's some other things that happen with irrigation. I just wanted to cover this in the introduction, that overwatering and fluctuating watering, too dry, too wet, that contributes to plant disease. So there's a lot at stake here when it comes to irrigation. Over-fertilization and overwatering makes kind of overly succulent plants that insects love, particularly the sucking ones like aphids. So that's at stake here. Insects, this is very insidious. They can detect stressed plants. They can sniff them out. And they prefer feeding on stressed plants. They don't have very good chemical defenses because they're stressed. So that's another problem with stressing out plants with poor watering practices. And of course, you probably know if you're an indoor grower, overwatering can contribute to increased dehumidification, whether they're portable units or an HVAC-D unit on the roof or outside on a pad. This increases your energy costs. So it'd be good not to water too much, just to think about that nexus of energy and water. And of course, overwatering contributes to algae and biofilms. And biofilms are one of the most challenging problems we have with irrigation and controlled environment ag. So the learning doesn't stop after today's workshop. We've got 2 more workshops that you can sign up for: managing peak loads and using renewables, then case studies and efficiency, where we'll actually take some of these best practices and demonstrate how they've worked in real situations. And of course, May 9th is also another great program that PG&E is putting on, Codebreaker, Controlled Environment Horticulture Energy Code. Okay, helps you understand how to be compliant. All right, we're gonna look at the results of our poll. Here it is. I'm taking most of our operations are between 5,000 and 10,000 feet. Oh, I should actually, it's a tie, and then larger ones are greater than 22,000 square feet. Very good. Thanks for compiling those, Carmen. So next, get my screen going. Yes. So next, I'm going to have Carmen Azzaretti do another poll question and give us a little bit of background about the California market and irrigation. Carmen, do you want to take it away?
Yeah, thanks, Rob. So this is a photosynthesis question. It's a quick knowledge check. So how much water do plants take up that is used for photosynthesis? So yeah, you want to roll me into the water?
Yep.
So kind of why we're talking about this and why this is important. So we've got a little bit of information about the California cannabis space. So just kind of the size of the California cannabis space. But then talking about water and why we're here. So agriculture in general as a whole, greenhouse, outdoor, indoor, etc., uses just a lot of water for irrigation. So here's a couple of statistics. So the USDA has estimated about 80% of water consumption in the US is from agriculture. So this is all types of agriculture combined. So as cannabis growers, this participating in agriculture and understanding our impacts are important, as well as the California specific impacts. If you want to go to the next slide. So California has cycles of drought and cycles of flooding, which I'm sure that you all living in California are very aware of. So paying attention to water in California and making sure that you can weather those periods of dryness and understanding where you're getting water from, and potential regulations that might be kind of starting to pop up around water use and water consumption in California. That's really important for us to keep in mind what our water use is like and make sure that our use is very efficient, as well as considering different potential ways to recirculate. So now we'll share the results of the poll. So plants take up about 1% of the water that's used for photosynthesis. So all the other water that's used is mostly dumped out through the leaves as transpiration and other forms. So it's kind of surprising how little is actually being used, but it is important for water to move different minerals and nutrients throughout the plant and all sorts of other things within it. But that water is actually kind of cycled out. All right, back to you,
Great.
Rob.
Thanks, Robin. Thanks, Carmen. And the next section we're going to do is efficient irrigation practices. We're going to start getting into the technical talk with our panel now. Thanks for doing that poll, Carmen. I think that's important that folks realize that even though we think about water and photosynthesis, it's just the plant doesn't need that much. Most of it is for cooling, and it is kind of scary to think just how much of it just kind of goes right out into the atmosphere when the plant's done using it, which is the basis of a lot of our environmental control problems. So I'm going to do the next poll, and then I'm going to turn it over to Derek. So if you could answer this poll, what controls the majority of your irrigation? That would be wonderful. And that'd give us an idea of the technology you're using out there. So next, I'm going to turn it over to Derek Gambrel, and he's going to talk about the efficient irrigation practices, efficiency through efficient irrigation practices. I'm sorry about that. Go ahead, Derek.
All right, so here we're going to talk about what is your culture around water efficiency in the workplace. How do you treat your resources, the water that you're using? You know, are we here in California, water is a very valuable resource that we need to treat very carefully and use it as needed and not waste it. So instilling a water conservation ethic, is your team all in the mind state that you're trying to use just what is needed and not wasting? Is your irrigation team routinely sharing data on water and fertilizer usage? Are you comparing notes, noticing that what the plants are using and making sure that you're using it the most efficiently as possible? Are you setting up any sort of reward system, setting goals as far as any way to reward employees for efficient use and conserving their resources? Employees can become blind to leaks in the systems. You walk past a leaking faucet, dripping, wasting water from hoses or from evaporative cooling pads, filtration systems, being mindful that we're not wasting our valuable resources that we have. Next.
Okay.
Oh, we skip one?
Sorry, my bad.
Okay. Along these lines of the culture in the workplace, accountability and documentation for maintenance. Are we maintaining our filters and everything frequently so we make sure that we're not wasting? Grab and go repair kits, supply kits, having tools close by so that if there is a break, if there is a leak, if there is some piece of equipment that is not functioning properly, if you've got the supplies and the tools there, you're more likely to fix it, nip it in the bud, take care of it, and get everything back in working order. Handheld moisture sensors are a nice little tool for your irrigation team to use to kind of give yourself some quantifiable data as far as what you're seeing in your plants, pot weight, how that feels, and being able to gauge and give yourself a quantifiable value for the dryness or wetness of your media. Let's see, equipment and ergonomics. Are all of your, keeping your, if you're hand watering, are you keeping your hoses unkinked and operational? Your hose heads and your wands, keeping them off the ground, free of bacteria and contaminants. Eliminating water and forget it mindset. Just because you've watered doesn't mean it necessarily was taken up by the plant and used by the plant. If you happen to have some dry down cycles, your soil becomes hydrophobic. You're more likely to get a lot more run through and just run through plants. With automated watering, emitter watering, a lot of times you can get channeling that happens through the media where your water is being put into one part of a media or a pot, and it just tends to channel right down through the pot and is not necessarily taken up by the rest of the media in the pot. Okay, so here we're going to talk about our different methods of watering. We have our good old hand watering with a hose. I'm sure everyone's done it. It's the simplest form of irrigation. It's you on the hose, giving attention to each plant one by one, going down your rows, down your aisles, and tending each plant individually. There are certainly benefits and limitations to hand watering. Some of the benefits is you're on each plant, you see it, you can kind of tailor your watering to, if you have a plant that is not drying down as much, you can skip over it. You can not give it as much. You can kind of tailor your watering as needed per plant. That gives you very intensive control over individual plants or zones in your cultivation space. I find with my team in our hand watering regimes, we're able to see and mitigate issues sooner. We notice pests, we notice inconsistencies in crops. As we're walking, as we're tending the plants, we're able to recognize any issues that may come up sooner than if we're just kind of treating the crops as more blanket and as a whole. There's clearly, so getting back to this mitigating issues, we have a little saying that the farmer's shadow is the best fertilizer. The farmer, the grower right there on a plant, you tending the plants, they tend to respond the best because they're getting personal attention, and therefore your crops will reward you. Limitations, it's incredibly time consuming to hand water. It can be very tedious, very labor intensive. It is not necessarily the easiest thing to implement in a large scale production system. Operator variability. If you happen to have a newly trained employee, someone that is not doing their job properly, someone that's not paying attention, not caring, you can get operator variability where the job may not be done as thoroughly as it possibly could. Getting over to automated watering, benefits and limitations there. Certainly much more efficient over a large scale cultivation operation, much more efficient, can cover much more ground, can scale it, depending on the size of your operation, you can just cover much more ground with an automated watering system. Therefore, it's going to probably take less people to operate and therefore give you a lower reduced labor cost. Limitations, installing a massive scaled automated watering system can be resource and cost, can cost quite a bit. It also takes regular maintenance to maintain the system. That is also going to cost the operator some to continue to maintain the system. Equipment reliability, if you happen to have a broken line, clogged emitters, clogged filtration system. If that goes unnoticed, if that goes unrecognized, you can certainly have crop loss, crop failure, lots of, the fallout from improperly maintained watering systems can be quite detrimental and can create quite the crop loss. All right. So plant culture impact on irrigation. What are we growing? How are we growing it? What are we growing it in? How does that affect our frequency of watering? How we're watering? Is it automated? Is it hand watering? Your container size is going to have a huge impact on irrigation. Are we talking about small nursery flats with seedlings and clones? Are we talking about 1 gallon, 2 gallon container plants? Or are we talking about large raised beds or trenches? Your substrate, growing in a traditional potting soil, a soilless media such as cocoa, peat moss and perlite, hydroponic in an aqueous solution, or rock wool. Planting density, are your plants spaced close together in a more sea of green setup? Or are we growing big monster plants and trees that have a huge root zone, that have a lot of buffer space within the substrate, where we can maybe not water quite as frequently? The genetics of plants is certainly going to affect your irrigation. We have small, stout little indica varieties that don't require as much water. We have large sativa varietals that get much larger that require a much more frequent irrigation cycles. The growth phase of your plants, what growth phase are you in? Is it a small cutting? Are we in veg? Are we in a transitional phase between veg and flower, where the plants are stretching exponentially, possibly 2, 3, 4 times its height in the first few weeks of flower? Are we later into flower, where we're toning down our watering frequency and hardening off and drying the plants off, getting ready for harvest? All right, Rob, next. So impacts of our environment on irrigation. All things to consider. What type of lighting are we using? Like just good old fluorescent fixtures? Are we using high intensity discharge 1,000-watt lamps, LED light bars? All of these different types of lighting will require different types of and frequencies of irrigation. Temperature and humidity. Clearly, higher temperatures, lower humidities are going to require our crops to be irrigated more frequently, while cooler temperatures and higher humidities, not as much. The vapor pressure deficit. Are we running high VPDs where there's a lot more transpiration, where there's a lot more water and nutrient solution moving through the plant? Or a lower VPD with less transpiration and not quite as much watering. Considering airflow in our cultivation systems, higher airflow, more transpiration, more watering, more irrigation cycles on the crop. So other tips we have here, grouping of similar sized plants together. This is something that we do in our houses, in our gardens. We will group varietals together. We will group plants with different harvest times together. Also similar sized plants together so that things can be treated in sections and in blocks. Half empty rooms require more irrigation more often because there's more ambient airspace, there's more air and more circulation, and therefore not as much moisture and transpiration from other plants that are creating an interplay amongst the canopy, which will allow for plants to not dry down quite as much. It is very advantageous to build healthy root systems early on. Being hyper intensive with your irrigation, with your proper dry down cycles early on to really get root systems to grow and flourish and stretch out into open soil and root zone to fill that out, to establish a strong root zone in the beginning so that your plants are strong and healthy and able to withstand stresses. Heft of pot watering. This is something that I instill in my crews and something that was taught to me by Rob in the very beginning, is just lifting pots, getting comfortable with what a saturated pot feels like and what a dry pot feels like, what's something in between, but it's just being out there. It goes along with this farmer's shadow mentality. You're just there with the plants, checking in, observing, lifting pots, and you'll be able to get a really good gauge as far as the dry down cycles and if things are going to be needing water now, in an hour, in a day. And it's just one of the principal key aspects is just lifting pots, checking for pot weight. This kind of goes into sense plant watering status. If you're there with your crops, if you're monitoring, if you're there, you just have, you can walk into a house, you can walk into a room, you can see a wilted plant off in the distance, you can see the a section of plants that are looking a little different. Color might be a little darker, a little off. And after a while, once you're in there, you're on it, you're walking around, and you can sense your plants will speak to you if you're listening.
Thanks, Derek. I love that. I was just about to ask you that question. Are there things that you've noticed, like particular strains or something that you've noticed? And it's fascinating to me that your eyes, with your experience, have adapted to be able to notice the color difference, with the very subtle color difference when a plant is beginning to show a little water stress, even before it's wilted down, I presume.
Oh yeah, I mean, I can sense the difference between the shade of green from the top of the leaf surface to the bottom of the leaf surface. And even just that little bit of droop. And when you're looking out over a canopy in, let's say, a greenhouse, you will see a color variation if those leaves are drooped a little bit, and you're seeing generally a darker top of the leaf surface, where you're like, oh, it's darker back there. I'm seeing more of the leaf surface, except for when plants are hydrated and they're kind of perked, and you see this underside of the leaf. And you can detect a color variation within a section, like, oh, they're dry, they're ready for water, it's time for an irrigation.
The other question I would have is there some strains that are kind of your indicators that those are the ones that are going to dry out first, or do you just keep an eye on the ones on the corners and the edge, because the edges tend to dry out first?
It definitely can be zonal in certain areas. I know that I have certain spaces, under like particular rows, if I have my lights boosted up in that row for later in flower. I do have some indicator plants. I have a sour tangy strain that's one of our bread and butters. We're very well known for. It uses a lot of water. It generally dries down sooner than the other varietals in the zone. And I know I can look back at my sour tangy, and it's always going to be the first to water. And it's kind of like my indicator varietal.
Oh, that's fascinating. One last quick question. I'm kind of cheating here. I'm not waiting till the end, but you bring up some of the good stuff. How do you do your weekend and holiday watering? Is that just you, or do you have any employees that will come in on those days?
We generally cycle. We will cycle our crews. Me as the boss, I generally will fill in some gaps if needed. I try to kind of mitigate some of those times to make sure I provide a solid, stable crew. But when we get into summertime and it's 24/7 and we're 100-degree days, I stagger my crews. So I'll have, maybe a Tuesday through Saturday crew, and kind of so that they overlap and interchange, so that there's no, like you taught me in the beginning, every day is a growing day. Plants don't take holidays. Plants don't know vacations. So they're always growing and they're always working. So we got to be there.
Fantastic. Carmen, can you advance the next slide? I threw this in there because I know we're going to be talking about hydroponics, and I want to make sure I get some terms out there before Andy takes over in the next section. So with hydroponics, what we mean is plant roots are in water. Either they're in a small little film of water, or they're in a deep container of water, or they're having water sprayed on them. Substrate is when you have the roots growing in some sort of solid substrate, whatever that be, peat moss, rockwool, perlite, okay? Also, we want to talk about the terms about, these terms are interchangeable: leachate, drain, runoff. When the stuff comes out the bottom of the slab or the bottom of the pot, I just want you to know these are all the same terms. I tend to use leachate. I'm not sure, Andy may use drain, but some people use effluent or overflow. Those are all the same. And the way you treat leachate, when we talk about reusing, is going to be the same way you treat another term, and that's called dump water. Dump water is when you're growing in, it's the waste from hydroponics. Typically you'll use hydroponics for 5, 7, maybe 10 days if you're lucky, and then you'll dump it out because that water has gotten so imbalanced you have to pour it out. So leachate and dump water are the same thing when it comes to treatment of it. All right. So here's our little diagram here that shows you on the far left, plant growing in soil. The next one is drip irrigation. I think you're all pretty familiar with that, where you're watering from the top of the substrate with a slow trickle. NFT stands for nutrient film technique, where it's hydroponics. The roots are directly growing in a film of water that's traveling down a sloped gutter. Deep flow technique is when you've got a container and the plants, and it's pretty deep and the whole root system is submerged. Aeroponics is when you're spraying water on the roots, a mist of water on the roots. And ebb and flow is when the plants either in pots or the roots, and I should say actually this is always in pots. Ebb and flow, the water, the table fills up and then drains, fills up and then drains. Okay. Next slide, and we'll get into our next. Let's look at the results from our irrigation control question. Looks like we have another tie. Time clock at 40% and using the climate control computer irrigation settings. It's great. Glad to see those. In fact, that is the natural transition. The first time you automate water, you go and you buy a little battery controlled timer, irrigation timer, I should say, and put your hose on it and get used to that and begin. That's how it all begins. But ultimately, you want to be there having everything integrated. And so you're using your climate control computer for your irrigation. All right, next slide. Great. So we're at the, I'm now going to introduce Andy to do our next section on automation of irrigation. Andy, I'll do this. I'll read this poll first. Thank you. If you all could answer this one, how is your water measured? And you can, this is one you could answer more than one. Is that right, Carmen?
Yep.
Great. So you can put more than one check in this. So if you just got 1 meter for the whole building, some buildings don't have any water meter buildings. I had a greenhouse like that, or more and more metering as you go down. All right, Andy, take it over.
Thanks, Rob. And just to clarify, I don't know who in the audience knows who Growdown are or what we do, but we manufacture stone wool substrate. So we were in the diagram of Rob, we were one to the right, basically, of the illustration in soil. Yeah. So I just thought I'd spend 2 seconds introducing Growdown. We do conduct a lot of R&D on cannabis. In the Netherlands, we have 3 licensed production research areas. This is just showing one of them. We've got 2 rooms. It's in a consortia called Cultivation for Compounds, and we're trying different agronomic techniques to see if we can influence the various output traits, the various cannabinoids, etc., of cannabis. And you can see the examples there of some of our research partners. So this growth room is pretty much typical of what we do and the kind of setup. You can see there's stone wool blocks there versus cocoa peat containers. Everything's fed with drip irrigation, although they're on ebb and flood benches. We've got dimmable LED lights from Fluence, and 2 rooms there. One is, I think, 800 micromole and the other one is 1,200 micromole. So place that into context when I kind of talk through what we're doing and why we're doing it. Okay, next slide, Rob. So I thought I'd come with kind of this statement of typical water use in controlled environment agriculture, sort of greenhouse situations. So, and Carmen, I've given it in liters per square meter, which is the tomato 1,250 liters per square meter, and Carmen or Rob have converted that into more of gallons per square feet per year. And those figures for tomato, pepper and cucumber are based on industry standard benchmarks. And if we take that into one step further, there is pretty much one defined growing system for those particular crops. There is an asterisk by cannabis because that's based on our data for our growing system, which I just showed you in the previous slide. But the take-home message here is, look how much water cannabis consumes relative to the other crops. Yeah, it's almost double. This is the message. This is why precision application of water, and what I'll talk about next in terms of drain water collection and recycling, is crucial. especially in areas where water is scarce. And typically what I see in the right hand column there is the EC. So that's the irrigation EC for those crops. And again, the 2.5 for cannabis is what we use in our trials. And if you think, I'll come on and show you a calculation. Think about the cost of the fertilizer. I won't include the water, that actually, if you don't capture it in the next part of my presentation, what you're actually losing per square meter per year or per square foot. Okay, Rob, next slide.
Just want to reiterate your point before you go on, Andy, that your cannabis measurement is less than the kind of industry standard we hear in the U.S. It's like a third. So when yours is double the other vegetables, but I think cannabis in the U.S. is even higher than the rate that you described right there. So it's a great point about how much water and, like you said, how much fertilizer is being used on this crop. Go ahead. Didn't mean to interrupt you too much.
So to put it in perspective, with tomato and peppers, for example, it's one cultivation cycle within a year, let's say. In that particular system, that 2,200 was for 5 cultivation cycles within a year, based on my first slide. So just coming back to, I think there was one of the first polls is, about the importance of water when it comes to photosynthesis. And there's the law of limiting factors. A lot of people will focus on light. But without water, it doesn't matter how much light you've got. So, and likewise CO2. So, the basic equation of photosynthesis, water, CO2, add light to provide the energy, gives you growth. So it's very important to optimize relative to the light, relative to the CO2, to have everything in balance to ensure optimal growth. So when and how to irrigate, of course, we talk about WC is water content, EC is electrical conductivity. So it's important for managing the water content and the electrical conductivity in hydroponic crops. Also the balance, people talk about the balance in the crop. So this is the difference between vegetative crop development, if you like, and generative crop development, which impacts on, as Derek said earlier, plant quality and root quality. So if you overwater, for example, you will damage plant quality. So it's very important to really focus and optimize your irrigation strategy. Okay, Rob. So Rob mentioned the best practice guidelines for greenhouse water management. Now, I actually wrote those with a company called Priva. So I've used basically illustrations from that booklet. And actually Priva, by coincidence, are also members of the RII. And before I forget, you can, if you would like, you can download that booklet from either the Grodan website or the Priva website, and it's totally free. So what I'm going to talk about today is basically taking snippets from that booklet, which of course was focused on vegetables, but I'm adding the twist into cannabis. So basically this kind of water cycle will come back. So moving from left to right clockwise, we'll talk about the source of your, sometimes call it primary water supply. So is it rainwater? Is it bore or well water? We'll talk about water treatment, sometimes referred to the water room, and the type of equipment that you may need based on your primary water quality in order to recycle and reuse the drain water. We'll very briefly touch on application and control. We'll deal with that in this section. And of course, we talk about drain collection analysis, and then the whole process of treatment, adding fertilizer again, and the cycle begins. So in terms of application and control, pretty much we're in the growth room where there's green things, or in the greenhouse, and we're talking about how we utilize sensors. Now, typically in cannabis, they won't be scales. It will be some kind of root zone sensor. And then you'll have some kind of control mechanism, however sophisticated, which will trigger an irrigation moment. Yeah, and that's coming from the process control side. So next slide, Rob. So when we talk about hydroponic, I'm talking about soil as substrate. So again, Rob, thanks for giving us that oversight. And typically, what I see in the cultivation of cannabis is it's either stone wool, sometimes called rock wool, but stone wool is the generic name, or it's cocoa peat. Basically, there are subtle differences in terms of crop steering, nutrient management, and of course, drain water capture and recycling. So you tend to get a little bit more, as you can see, from more vegetative growth from cocoa peat. Depending on if it's washed or buffered, will affect how you collect and reuse that initial, what sometimes we call first flush. So that first drain water that comes back from the substrate. But it can be done with both, but there are subtle differences. Next slide, Rob. So Rob mentioned, drip irrigation in terms of substrate control. So these are the kind of the white laces that you see in the stone wool blocks in the top picture. Now, typically in controlled environment agriculture, you can have 2, 3, or 4 litre per hour drippers. Now, there's a trade-off between their resaturation properties, so that's giving you the control over the water content, and their refreshment properties, which is giving you the control of the EC in the substrate, so the electrical conductivity. So if I can take the analogy of a dry sponge, and you put that dry sponge under a tap, and you turn the tap on so it just drips, that sponge will gradually get wetter, wetter, and wetter. If you put that same dry sponge under the tap and you turn it on full, the water would just run straight through the sponge. So that's what we're talking about. For example, the difference between a 2 litre and a 4 litre per hour, it's the rate at which the water comes and how it is partitioned in the substrate between resaturation and refreshment. So typically in the system that you see in the top picture there, we would recommend 2 litre per hour drippers. It's giving water around 33 mil per minute. The bottom picture shows you the different types of pegs that you can get. And I just, I put this in just as a heads up. So the picture on the right is really showing you an open channel kind of irrigation peg. And, my experience, these are quite cheap, but the water just runs down that channel to the bottom of the substrate and back out again. So they're not really effective. So more effective is to have the dripper on the right-hand side. And if you look closely, you can see, rather like you put in a sloping path, you put kind of drain channels to deflect the water off the path so you don't wash the path away. It's kind of got grooves in its side walls that allow the water to trickle away in stages. So ultimately, the capacity that you use is going to be dependent on the crop and the system. So for example, in vegetables, in tomato cultivation, we would use 3 litre per hour drippers. If it was peppers, because there's more per square meter, we would use 2 litre per hour drippers. Yeah. Crucially, these are all pressure compensated. And what that means is they all open and they all close at the same time. And this is crucially important, especially in big greenhouse situations where you've got pipe lengths of 80 to 100 meters. Yeah, so it ensures that the plants at the beginning of the row and at the end of the row all receive the same volume of water, because all of the drippers, they open and close at the same time. As I said before, for the system where we do the trials, we recommend 2 times 2 litre drippers per hour, located in opposite corners of the block. And that block, for example, is a 3.2 litre block, sometimes called a Hugo block, I think, in North America. Mm-hmm. Next slide. So application and control. It's coming down to root zone sensors. So, you know, no apologies for showing you the GROD and the GrowSense sensor in the block there. Now, from that sensor, we create graphics. Now, we are, despite all of the comments you see in the press about autonomous control and AI, pretty much 99.9% of the time, we are still reading this data descriptively. Yeah. So we're interpreting data from our, from our experience. And then finally, what we're doing is we're implementing then or fine tuning set points on a climate computer. So to put it in, there's a poll on size in situations, where I'm normally operating. In England, the largest cannabis grower in the UK is 240,000 square meters. So times that by 10 to get it into square feet. So hand watering is not an option. Everything is automated.
Yeah. Next slide, Rob.
So what does the sensor do? Well, of course, it should be reasonably accurate. So within 2% water content, 0.2 millisiemens per centimeter. And ideally, it should, of course, have a graphical interface which you can scale and which you can visualize. And if you've got a climate computer, you should be able to add that data to the climate computer. So as a grower, you can add things like the light intensity to it. Yeah. And from this information, we can fine tune the irrigation start time. We can fine tune the irrigation stop time, and we can determine the frequency and volume and the lengths of the irrigation cycles that we need to give. So making reference to my next kind of talk on drain water recycling, it's pretty much making sure that we supply precise amounts of water so we have less drain water in which we need to capture and recycle. Yeah, so the process starts with precision application. Next slide, Rob. So what I show you, and I'm not going to talk through it now, on the right-hand side there, you can see some print screens from the Priva climate control computer. And the way that we set up irrigation, there is on the bottom screen there, your picture, you see the start installation. And then on the top, you see a start strategy. And you can see columns called in per 1 to per 8. They're called periods. So in any 24-hour time frame, I can set up to 8 different periods. You can be as complex or as simple as you like. And I can tell the climate computer in each period in the installation start screen what parameters should trigger an irrigation. Now, you can imagine if I'm more in a greenhouse situation with a lower level of artificial lights, the more options I may need because there is going to be greater influence of the outside environment on plant transpiration. So, these climate computers were typically made for greenhouse vegetable production. And they allow growers, for example, to optimize the irrigation start time, stop time. Usually, this is based on light sum or light intensity, can be also a maximum rest time, can be clock starts, can be based on a calculated rate of transpiration, can even be based on a percentage water content of your substrate or weight. They also allow users in this particular example, in line 6 on the top screen, you've got a start phase. That's the volumes. So we tend to work with larger volumes in the beginning of the irrigation day, and I'll come back to explain that why later, and then smaller volumes as we go through the day. And basically through the light sum and the light intensity or maximum rest time, we can alter the volumes and frequency of which we give irrigation. So there's more information in the guidelines, but essentially if you're inside in a growth room, simply clock starts will be good enough, because the sun rises at the same time every day. It's the same light intensity. It's the same temperature. It's the same humidity. It's a lot less complex than it would be in a greenhouse. Next slide, Rob.
I put a link to that guide you referred to in the chat
Okay.
for everybody.
Okay.
I also just wanted to throw out this this idea that these greenhouse controls are very, very sophisticated because they have to respond to weather and do it quickly. And don't let anyone convince you that building controls, even if it's a global company worth billions of dollars, sometimes they'll come up with products to try to control greenhouses. And typically that, I don't want to say their names because I'll get in trouble, but typically that doesn't work. Buildings are not designed to, they don't have plants in them and sunlight, and the changes don't happen so quickly. So you really get, once you get to this point where you're going to go with a climate control computer for your greenhouse, focus on the ones that actually are designed for greenhouses. Sorry, Andy, take it over.
No problem. So what I've shown you here is basically the effect of outside climate, and that's so what I've got here is the blue line is the substrate water content, and the red line is the substrate EC. It's coming from the grow sense sensor, and I've connected that data to a third-party data source, the climate computer, and I've simply added the light intensity, and you can see I've got three days, and the white lines indicate sunrise and sunset for each of those 3 days. And I've chosen this to give you an indication when you get the set points correctly, when you're dealing in greenhouse situations, that for 3, so you see the blue sky day in the middle, yeah, and then 2 very different days either side. But crucially for the plant, with an optimized irrigation strategy, the plant sees no change, because the water content is exactly, the day level, so the flat part of that graphic, the day level water content remains exactly the same. If you look to the decrease in water content overnight, it's exactly the same. The EC doesn't increase on the bright day, it doesn't decrease on the dark day. And simply, when you need to help the plant the most, you can look when radiation is highest, is the EC lowest? Look in the middle of the blue sky day. So for me, this is a textbook example of precision irrigation in using a process control computer in a greenhouse situation. So next slide, Rob.
Nice.
Now, when we go to a growth room, it's a lot, in my opinion, easier, because the black lines there represent vertical. They represent lights on, and the one on the right, lights off. So I'm showing you now a typical irrigation strategy that we use in our trials, for a kind of, I've kept it simple, a plant in the flower stage, under the 1,200 micromole, the temperature might be 27 degrees, for example, So simply we start irrigation 1 hour after the light's on. We give an irrigation gift, or something that's called volume. Sorry, gift is a Dutch term. I work for a Dutch company, So we give 3% of substrate volume, and in the system that I showed you, they're around 3 litre blocks, So 3% is around 90 mil, and we do that every 30 minutes until the EC is stable. That's a general rule, So you can see these cycles. Maybe it's the first 8 coming quite quickly, and then once the EC is stable, so coming down and now stable, we simply reduce to every hour, and we stop 1 hour before sunset. And that's pretty much when your plant is in, it's simply, you're just monitoring to make sure that you're still on track. There's very little changes that you need to make to the set points. So I'll explain a little bit now. So you can probably see that there's each one of these peaks is an irrigation moment, and you can see plus minus about 16 irrigation moments in that day. So if you do the calculation, if it's 96 mil, per irrigation moment, That's about 1.52 litres per block in that. And I've got 7 plants or 7 blocks per square metre. So I'm giving around 10.7 litres per square metre per day. And to keep it kind of simple, the decrease in water content. Now, typically in vegetables, we work between 8 and 12%. And we grow that we try and follow a similar strategy for cannabis. And I think if you look to the scale, this is around 12%. And if you do the calculations, actually, 12% of a 3.2 litre block is around 384 mil. So what that block loses overnight is 384 mil. Of course, after per square metre, I times it by my 7 blocks. But this is why we need in the morning to get back to that same day level water content. I need to account for what that plant has lost or block has lost overnight, plus what the plant is transpiring the next morning. You know, the graphic on the right. So you can see I'm pretty much getting EC control around 8 irrigations. So that's pretty much double what the plant has lost overnight. And those basic general rules, when we look at this data, it's very easy to see what we need to change. Is it the start time? Is it the stop time? Is it the volume? Is it the frequency? So they are simple touch points that we use to keep stability when it comes to a grow through. And I'm sure there's people in the audience that have their own kind of rules of thumb as well. But I just thought I'd just highlight that for you. Next slide, Rob.
Yeah, we're going to cover our next poll results. 1 meter on the incoming water is what 80% of you answered. That's very typical. Carmen, next slide. We're going to let Andy keep going. Now we're going to talk about remediating irrigation water. We're going to do a knowledge check first. And what are the 2 most important measurements an irrigation should take? Okay, so you can answer that during the section. Andy, if you know fault of your own, mostly me, we got a little bit behind, so you may have to push this one a little bit faster.
Push on through. No worries.
Next section. Next slide, Carmen.
So typically then we've been recycling the drain water for years in greenhouse hydroponic vegetable production. It does require certain tools, and the possibilities and capabilities are all down to the scale and size and complexity of your facility. So this is a typical greenhouse that we see in the Netherlands. It's got 1 crop in there, 1 variety, 1 planting date, wow, and it's all removed on the same day. You can see the the rainwater reservoir there. So it's pretty simple. Yeah, there's no mother room, there's no veg room, there's no flower room, there's no different fertilizer recipe. It's simple. Yeah, so you have to consider, you know, if you've got a different fertilizer recipe for your veg room, you've got a different flower room, and you're collecting the drain water and you want to keep it separated, well, that's 2 drain basins. It's double the cost. Yeah, so it all comes down to scale and complexity and your own situation. So I'm just going to give now higher level touch points of certain considerations that you may wish to use. Next slide, Rob. So why? Well, I think Rob mentioned the quality of surface water from nitrate and phosphate runoff. Certainly, it's a legal requirement now in Europe that we cannot discharge, I think, Rob, you called it effluent, yeah, dump. We cannot discharge wastewater from the greenhouse. We have to use everything. Of course, legislation drives innovation, but through recycling, as well as protecting the environment and complying with legislation, we also reduce our fertilizer costs. Next slide, Rob. So this, I've given you it's in millimoles per litre. we can translate it to parts per million if that's what you use. I'm not quite sure. But typically, what I've showed you there is the regime that we use in our trials. So if we want more vegetative steering, we'd irrigate that, say that with 2.2 EC. More generative would increase it to 2.5. But I'll just run through the costs, for example. So typically 2.5 millisiemens per centimeter, roughly, don't hold me to this, it could be 0.7, it could be 0.8 euro cents, yeah, per EC unit, yeah. So, and if I'm using 2,200 litres, I simply do the maths and I can calculate that my fertilizer cost is 3.3 euros per square metre. And if I recycle, if I assume 30% drain and I recycle that water, I can reduce that cost to 2.3 euros a square metre. Yeah. So it just goes to show you that there are, yeah, cost savings to be made. And if you imagine again, how much you save will depend on the size of your facility, which will then govern whether you invest or not. Yeah. Next slide, Rob.
Andy, real quick, do I understand that you use the same nutrient formulation, but just change the EC?
Yep, we do not have any magical potions.
Okay, thank you.
It's what it is. Yeah.
That's fascinating. That's great. Thank you.
Yeah. So coming back now, we've dealt with application control. We'll deal with water sources, water treatment, and collection. Next slide, Rob. So water source. So sometimes primary water in the picture I showed you is rainwater. It's the best source of water, but in California, you can, I remember from the initial slides, it can be somewhat intermittent. It's law, for example, in Europe that we need a certain rainwater storage capacity, and that's 500 cubic meters per hectare. Typically, growers will have more than that, around 800 cubic meters per hectare. So the primary water source is rainwater. If we need another source of water, it's normally bore water, sometimes called well water. We would never use surface water, river or a pond. Why? Because its quality can change quite quickly, and it can also be contaminated by agricultural runoff. And it's very important that you at least sample your primary water supply once per year. And if you change it, you need to sample it again. And the kind of table below, you can find it in the booklet that Rob's referenced, gives you some kind of indication of the quality of water that's required. So the take-home message here is, if you've got sodium in the system, you need to remove it, because the plants don't take it up and it will just accumulate in the system. And then at some point you will have to release that water to the environment because of the sodium buildup. Next slide, Rob. There are also other subtleties that you should be aware of, particularly with bore water. If you're using that, particularly with deep wells, they can contain a lot of iron, and that iron needs to be removed because it can block the irrigation system. So if it's fairly low concentration, simply aeration will turn it, oxidize it, turn it to rust. If it's higher, you probably need a reverse osmosis unit. Next would be, if you've got quite high levels of bicarbonate in the water, you may need some form of pre-acidification prior to that water going to the fertilizer mixing tank. And again, sodium is the killer for drain water recycling. If you've got it in the system, you need to remove it. And just a point, sodium can be selectively removed from the drain water with such systems. It's called the NONA from RIDA. The capacity of those systems, certainly in the big greenhouses, is not sufficient to remove it from the primary water quality supply, but certainly sufficient to remove it from the drain water. And the beauty of this is it's selective only for sodium, so leaving all the good things behind. Next slide, Rob. So I've mentioned this, so minimum 500 cubic law. So ideally, you'd have the drain water storage tanks, both dirty and clean inside, they'd be covered, and the capacity, of course, the size of your facility multiplied by the expected runoff in any 24-hour period. Next slide, Rob. So water treatment, there are lots of options available, but given the constraints on time, I'm only going to deal with UV. Why? Because it's the most common. Why is it the most common? Because it's simple, it's effective, and it's cheap. There are different kind of strength of the UV light. So typically 150 joules for bacteria and fungi. If you need to control viruses, typically 250 joules. Be aware of the T10 value. That's the transmission rate of the lamp. So the top picture there shows you a initial drain water from stone wool versus the initial drain water from cocoa peat. So that initial drain water from the cocoa peat on the right is probably too dirty for effective T10 transmission. Now, you can do one of two things. It can be diluted, or you can invest in more expensive equipment that look to systems which will modulate the flow and the intensity of the UV system to try and attain a certain T10 value. Next slide, Rob. Fertilizer dosing. So again, typical picture of the stock tanks and the dosing unit on the right there. Now, when it's drain water recycling, we need to do is we need to combine clean drain water with new fresh water before it goes to the fertilizer dosing unit. And typically this is controlled by a valve, and we call it the ECS, or the EC supply valve. And that valve will typically have a setting on it. And what we would typically use is 0.8 millisiemens. So what that effectively means is that my system will take drain water, it will blend it with fresh primary water to an EC of 0.8. And if my target irrigation EC is 2.5, meaning I only need to add 1.7 of fresh nutrition from the fertilizer dosing tanks. Now, what you can do towards the end of the cultivation, but again, it depends on the way that you cultivate, you can increase that EC supply value. So, for example, we may increase it to 1.2. What does that do? Well, it uses proportionally more of the drain water in the drain basins. So therefore, towards the end of the cultivation, you lower the volume of drain water in the drain basin. The idea is to have it empty, so when the next crop comes in, it's ready for the first flush.
It's so clever. I love that. I hadn't heard of that before I read your book.
And basically, this is the last slide. Yeah, when it comes to drain water recycling, it's all about tiny adjustments and minimal change. And typically what you do is you take an analysis, ideally every week, every 10 days. That analysis is then adjusted. That's the second line to the EC that you're normally, it's adjusted to the EC that you're irrigating at. And it's adjusted based on a certain calculation, normally the level of sodium or chloride. We don't have time to go into it. And then it calculates a new target. That's the third line. And then programs like NetFeed from Grown Agro Control will tell you what to put in your A and what to put in your B tank. Yeah. That's it, Rob. Yeah, so in summary, to measure is to know. Crucial is your primary water supply. Take regular analysis of the drain solution for timely adjustments. Remember, the higher the EC that you can work on, the more possibilities you have for corrections and drain water recycling. And of course, to put this back to your own situation, you need to consider scale and complexity. And then from that, make the sound financial investment decisions. Thank you.
Great. Thank you, Andy. That was wonderful. And Another thing I seem to learn the more I read is that water usage, water quantity is determined by water quality. If you can start with, if you're recirculating, if you can start with water that doesn't have sodium in it, or you get it really low, you can use that water a lot longer. And so you don't have to replace it so often. Water quality determines water quantity used. Okay, we're going to look at this. We're going to look at this knowledge check. And Carmen, did that pop up? I missed it. I'm sorry. Yeah, okay. The two most important measurements for an irrigation sensor are water content and EC. Okay, next slide, please. So I'm going to do a quick notion of bringing it all together. Next slide. So as you're making decisions about the priorities, there's a lot going on here. There's a lot of equipment to decide between, and it helps to get some priorities. And I think I've kind of boiled it down to this. You want to restore water quality, okay? So that for the protection of the plants, if you're recirculating, that's first priority. Second one is removing biofilm, because the biofilm can get in the pipes and get in the drippers, and biofilms can actually harbor plant diseases and human diseases. So it's important to use a disinfection along with UV, which is just so effective. It also helps to combine UV with something like ozone or chlorine dioxide, or one of the peroxylated acetic acid products that'll go after that biofilm as well. And we want to reduce reject water. So RO is kind of the enemy here. We need it to purify water so that we can use it longer, right? But the problem is when you use reverse osmosis, there's all this reject water that goes straight down the drain, and it's a lot of waste. So choose systems that you can nullify the amount of RO. And Andy said the magic words, you know, you can use rainwater if you're in an area where it gets a lot of rain, or if you've got HVAC units or dehumidifiers, using that condensate is also very good water to reduce how much RO you need. Kind of use that instead of RO water. And as Andy said, recovering nutrients, because that's how you're going to pay for this. Next slide. I'm not going to go through this chart, but I provided it for you because you're all going to get a copy of this deck. And this talks about all the different technology and what it does, what it gets rid of, agrochemicals, pathogens, and how much it might cost compared to other things. Does it have how much space does it take? Like that's the footprint column. So this is here for you to use. Next slide. So quickly, a schematic. If you look at the box that says irrigation and drain, that's the greenhouse, right? And the irrigation is in those red lines, and it's going through the plant and into the drain and then out the drain tank and being discharged. The water's coming in from the blue diamond, the source water, bore water, groundwater, to a fertilizer mixer, into a fertilizer tank, and then into the greenhouse. So how do you get to the next stage? Without scaring you, we're going to go to the next slide. Don't panic. This isn't that bad. Go ahead. So now what you do is you've got that source water, that blue diamond up at the top. You're putting that through an RO, reverse osmosis, and you're making purified water so you can use that water a lot longer. You're also putting rainwater, using rainwater so you don't have to use that RO water so much. So the rainwater is the other blue diamond. And in fact, there's another blue diamond HVAC condensate far on the right. So you can use those two sources and put those all into your purified water tank. You don't need the bore water, the well water, or the surface water. You don't need very much of it because you're getting it from all other sources. And it's all purified, and that's what you're going to use to dilute with that EC valve. You're going to dilute that leachate that's come through that whole system. It's going to be disinfected by UV and what have you, and then you're going to measure it at that 0.8 value that Andy talked about, and then add purified water to it and recharge it with nutrients. Okay. And anything that gets discharged can go hopefully to a biological way of controlling it, or it might go to a standard sewage treatment, or you could evaporate it off. Next slide. Okay, next I'm going to turn it over to Mary McDonald. Again, the tool lending library and class coordinator, and she's going to talk about some of the programs, and she's also going to remind us about that survey, because it really helps us to have that survey done. Mary, you want to take it away? Next slide, Carmen. Okay. Mary, are you with us? You want to do this? I can do this as well.
I was not off mute. I was going on and on.
I should have checked that.
So-
I apologize. I wasn't watching the little microphone. Okay, go ahead.
So normally I just do my mic anyway. So yes, I have put the chat or the survey link into the chat. Please do give us your feedback. We'd like to know what you thought of today's class, what we did right, what we could do better. It's all important feedback to us. A few things about the utility resources. This is a little bit about how you do an application for new service installation or an upgrade. That's when you need a new power service. And so you do submit your application at yourprojects-pge.com. I know it's been a very, very slow process. We are working on improving that. So my recommendation to you is if you need new service, get that application in soon, early in your project, and get a customer representative assigned to you who can help you. They can help shepherd you through the process, and you can call them if there are any questions. So there's the customer service number and the building and renovation service center. Next slide. We do have our third-party program. This is our agricultural program, the Agriculture Energy Savings Action Plan, run by TRC companies. And they do provide rebates for grow lighting and controls, greenhouse and heat curtains and IR films, insulation, boiler or heat recovery, and for irrigation upgrades. So if you do want to do an upgrade, please feel free to contact them and see how they may be able to help you with incentives, and their services are free. I think we have a little more about how to apply for things in the next slides. So there's the rebate process. This is for something that's deemed. You can just purchase the equipment, submit your application, they review it, and then sign off, and you get a check. On the next slide, we have a slightly more complicated and slower process. This can be 5 months and more. This is a custom process. It does involve, you have to apply first, get it approved, get it installed and verified, and then they will calculate the incentive for you. So this involves more pre and post monitoring. They also have on-bill financing and go green financing. Next. Okay. Oh, I am not sure. There we go. And there's their contact us page. You can, at their website for the ASAP program, you can ask them to contact you, and they are very helpful in defining the process for you. Next slide. All right, we do have tool lending libraries. There's one in the SCE territory, that's Southern Cal Edison, and also ours in the PG&E territory. We loan energy measurement tools for free. If you need to know what your temperature and RH are, we have lots. That's relative humidity. We have lots of monitors for you. We have meters where you can do quick surveys, loggers where you can do logging over time to determine trends. We also, in case you are looking at your irrigation and you do only have one flow meter or one meter for your service, you can submeter that temporarily using our ultrasonic flow meters. They're non-invasive. All you have to do is attach them to the outside of the pipe and then program your flow meter, and you can monitor flows. These are all free. There's other tools we have too. If you don't know how to use these tools, we also give you tutorials. We have app notes to explain how to use them, and we will support you in the field if you have difficulties in the field. So you can register at those two links that are in the slide. Next.
That flow meter is so cool. Ultrasonic flow meters, they can just clamp on and move it around. Just want to remind everyone what a great program you've got going there. Go ahead, Mary.
Yeah, our flow meters are actually getting super popular.
Bet.
With me being our agricultural tech lead here, a lot of agricultural companies are borrowing those for pump tests,
Yep.
which if you all, I know you all might have deep wells and the like, we do offer a series of classes on pumping efficiency. So feel free to reach out to me. I'll put my my email in the chat, so reach out to me if you want to find out more. And I think you all know a little bit more about the statewide programs for producers than I do.
Thank you, Mary. Next slide, please. So we've got just a few minutes left, and we want to ask each of our panelists a question because we love storytelling. This is Carmen Azzarati, our engineering operations manager, who's been helping today. She and I both love this part. So we'll start with Derek. Derek, can you tell us a story about an irrigation nightmare or something, or maybe someone who did everything right, but it still didn't turn out well, or something that has happened to you? We just love to know what people need to look out for.
Well, through the years, we have operated quite a number of farms with they're rurally located, you know, kind of in the hills of Mendocino County, operating with stock tanks, storage tanks that supply our supply water that comes from our wells to our supply lines. Most of it operates on gravity. So we're putting our tanks uphill from our operations, pumping to the tanks, and then the supply comes downhill via gravity to give ourselves a pressurized system for our grows. Well, there was a time where I had a very close friend and brother managing a site while I was out of town. And he happened to, he happened to leave the valve on from our tanks and thought he did his job. It's a very, very common thing that happens. And, you know, we have our pickle barrels, our stock tanks, our fertilizer tanks, and he did his watering, he did his rounds, took care of the crops, and forgot to turn that drain line, forgot to turn that supply line off, and drained, oh boy, it was tens of thousands of gallons through our stock tanks, through our equipment rooms, into the grow, and flooded the entire operation. I show up, you know, a couple days later, and just water is just spilling out of the facility, out the cracks, and just feet and feet of water, and just the entire operation is, I'm swimming, swimming, and oh boy. Yeah, it happens. It happens to the best of us.
Yeah, that happened to me as well. That something broke overnight and the irrigation just kept running and running and running. And so it just drained a stock tank of fertilizer, and you know, 200 parts per million nitrogen, or a 200-to-1 ratio of stock concentrate to water. That was a lot of nitrogen I put down the drain. It's just, to me, we came up with a fix after that. We just had a timer that wouldn't allow, we just shut off the injector. Derek, do you think your issue was just a one-off, or did you do anything to try to prevent from happening again?
Float valves. We put float, we installed float valves on the tanks now, so that just can't happen. Manual or automatic electronic float valves. So that
for me, for solving my problem, I didn't have to spend any money. I just was a dummy, and I didn't realize that I should go in there and program the injector to not be allowed to work after a certain time of night, because there's no reason for it to be running after, in my case, 10 p.m. Right. We'll turn it over to Andy. Andy, anything gone wrong that you can give us a warning about? Or has it all gone perfectly?
A common mistake that I see is that the size of the fertilizer mixing tank is too small for the size of the facility.
Mm.
And that, because that the water and fertilizer mix is in there for a fraction of seconds, it basically doesn't allow, if that tank is too small, remember it's just pulsing too quickly, and then the acid doesn't have time to adjust the pH. So the pH will fluctuate going to the crop, but the way that the pH or alarms are structured, it just reads the average of the fluctuations, so it doesn't alarm. So, you know, key is make sure that you buy or you have a mixing tank of suitable size for the area of growth room that you're irrigating.
Right. So you really need to have horticulture water treatment experts helping you with this.
Seek advice. So basically, any of the manufacturers worth their salt should be able to tell you exactly what you need.
I agree. Well, we're going to sign off.
Knowing to ask that question. That's all.
Yeah, well, sometimes you don't know what questions to ask, and that's why you need to bring in people who've been in these folks, these technical reps from water treatment and irrigation firms. They've been in hundreds of greenhouses, and so they've seen it all, and they are willing to share that expertise with you. So take them up on it. I'm gonna say goodbye to our audience and thank everyone today. Derek Gambrel of Redwood Remedies, Andy Lee from Grodan, Mary Lucas McDonald from PG&E. For Carmen Nazaretti, I'm Rob Eddy with Resource Innovation Institute. Thank you for your attendance today.